So, we are in geometry. Sam, Beverly, we're okay. Today is March 6th, 3/6. Today we're talking about sectors, specifically sector area. All right, so what is a sector? A sector, let's go ahead and make a picture. If I have a little pie slice, here for my sector, this pie slice is technically a sector. So the word that I'm going to be using here is, and I'm going to do this in quotes because it's not mathematically formal, it's a pie slice.
I guess they just jumped right over my seat. Because you weren't even here. They still have gone by.
Who else? Are we missing someone today?
Drew's not here.
Drew is here today.
Not the seat. Yeah, but he gets privileges, right?
Why do I have an extra thing of notes? Who's not here?
Leo.
Yeah, okay, thanks.
Why is Drew's
All right, so we have a pie slice. The more formal definition is it's part of the area. And I guess even more formally, I'm not going to get too formal, but it has to be an area from this central angle. All right, so we need two formulas today. One of them you should know. What is the area of a circle? And I haven't passed out cards yet. Who wants to help me pass out cards? Colby, you want to do it? No? Really, you want to pass out cards?
Sure.
Sure.
Yes, sir.
All right.
I have to go all the way.
Area. What is the formula for area? There's 3 people that know area. There are only 3 people that know? Uh-oh. All right, Anna, go for it. Pi r squared. There it is. Yeah, Anna, you can turn in your participation card and get it. All right, there is our marble. I'll come back and do XP at the very end. All right, so sector. To find the sector area, there are 2 different ways of doing it depending on what type of central angle I give you. Again, when we're talking about angles, we can be talking about degrees, or we can be talking about radians. Aurelio, please don't touch other students. All right, so for degrees, the way that I find sector area is I do the angle, whatever angle I'm given, and I divide that by 360. That is going to be equal to the sector area. Should we please stop? That is going to be equal to the sector area over the total area. And when I say total area, I'm talking about the circle. If that is confusing, you can do a little circle in the bottom right-hand side. It's called a subscript. All right, radians is essentially the same formula, but I need to convert one of the numbers to degrees. Who wants to do that formula for us? It's basically the same, but I need to convert one of those numbers to radians from degrees, because technically 360 is in degrees. Thank you, thank you. Who wants to write down the formula for us? Tell me what it is. It's the same thing with one number changed. No one wants to give it a shot? Go for it, Ellery. Theta over 2 pi. So far, so good? There it is. Sector area. I can't spell. Sector area divided by total area. Please stop. Total area. All right, let's apply these formulas. I have 3 examples for us. Example 1, 2, and then we have 3 on the back, and then we'll be done. All right, so the key part for each of these is to analyze what's happening either with the picture or with the text. If you can't tell if 25 pi is talking about sector area or the area of the circle or the angle, read what's happening in the text. All right, Easy XP here. Someone read example 1.
We just have to read it.
Just have to read it. Beverly, yep.
A circle
Damn.
with area 25 pi has a central angle of 2 pi over 5. What is the area?
Perfect. All right, so from reading that, we know that this 2 pi over 5 is an angle. It's not the area, this is the angle. Thank you, Beverly. You can turn in your card. All right, so I need someone to help me set up the formula. Which formula should I be using? Am I using radians or am I using degrees? What does this look like? Does it look like it's in radians or does it look like it's in degrees? And then help me with the formula. Go for it, India. It is in radians, so we're going to be using this red formula on the right-hand side. 2 pi divided by 5 for the numerator. And then the denominator is indeed 2 pi. $25 for the denominator. All right. Oop. And then x. Yeah, the thing that we don't know. Yeah, thank you, India. You can turn in your card. That's a marble. All right. So far, so good. We have set up our problem. We just fill in what we know. It's always going to be 2 pi, so we always know that. All right. So it sounds like some of us need to switch from a pen to a pencil. Who has the pen? Who's making the pen sound? All right. Is it Martine now? Not your pen? All right.
Wow, look at me.
All right. From here, I need to solve. So this is a fractional equation or fractional expression where I need to do a fraction divided by a fraction. So I'm going to turn this into 2 pi over 1 for the bottom. 2 pi is the same thing as 2 pi over 1. All right. I need one more volunteer to keep it, change it, flip it. The left-hand side, keep it, change it, flip it. Who can help
Why did
us?
you put like /1?
Because 2 pi is the same thing as 2 pi divided by 1. I can always have a denominator of 1 on anything. So from there, keep it, change it, flip it. Who can help us? I need to keep the numerator. Leave it 2 pi over 5. I'm going to change it from a division problem, this divided by, to a multiply, and then I need to take the reciprocal of my bottom. Who can do that for us? Only one person. That's not good. 2 people. Colby, you want to take a shot at it? Go for it. Keep it. Keep the numerator. So just rewrite the numerator.
Power 5 times 1 over 2 pi.
1 over 2 pi. Everyone write it down. We kept the numerator. We changed it from a division problem to a multiplication problem. And then we flipped the 2 pi over 1 to 1 over 2 pi. We took the reciprocal. So from there, I'm going to rewrite the right-hand side of the equation. The right-hand side is still x over 25 pi. X over 25 pi. All I did was I changed the left-hand side using the keep it, change it, flip it rule. You will be doing this keep it, change it, flip it rule over and over on tonight's homework. All right, I need someone to reduce the left-hand side of my equation, this expression on the left, this black stuff. How do we reduce the black? How do we get this reduced so I can cross off stuff on the top and the bottom, the numerator and denominator? I see one person knows how to do this. 2 people, 3 people. Do any of those 3 people have cards? No? Does anyone else want to participate that still has their card? 4 people. Gloria? Yeah, go for it. Yeah, it turns into 1/5 because the 2 pi's cancel out. Exactly. Yeah, so this whole left-hand side is really 1/5. So if I'm rewriting my expression, I'm going to squeeze it down here in the bottom left. I have 1/5 on the left, as Gloria told us, and that's still equal to x over 25 pi. Thank you, Gloria. Marble. All right. From there, I now need to solve. Whenever I have a fraction equal to another fraction, I do this technique. What technique? Beverly, go for it. Oh yeah, that's actually way faster. I can just multiply both sides by 25 pi. So I'm going to come up here and I'm going to say, right now x is being divided by 25 pi, so I can multiply by 25 pi, multiply this side by 25 pi. I'm trying to get rid of the fact that I undo this dividing by 25 pi, so I'm multiplying by 25 pi. I'm taking the inverse operation. All right, when I do that, these 25 pi's will cancel out, and I'm left now with x on the right-hand side, and I now need to reduce the left-hand side. I need a volunteer. Help me reduce that left-hand side. I now have 25 pi on the top, because you're really multiplying by 25 pi over 1. 25 pi on the top and 5 on the bottom. Who can reduce that for us, Ellery? 5 pi, yep. This is just equal to 5 pi. So the answer is 5 pi radians. All right, that was example 1. Any questions on example 1 before we move on to example 2? No questions? All right. I think we need to pause and we need to stretch our legs because we need to get away here. So we are on example 2 now. So we have a sector area of 4, central angle of pi over 3. I'm reading this for us. So that means that this is the angle. Pi over 3 is the angle. All right, shout out if it's in degrees or radians. Go. Oh, God.
Radians.
It's in radians. If you see a pi, you should probably assume that the angle is in radians. Although I guess I should make that clear by saying that is a central angle in radians. But usually, if you see pi and that's the angle, assume radians. All right, and my sector area is 4. I'm trying to find the area of the circle. So I have the area of this pi slice, the area of the sector, but I need to expand that to find the entire area of the circle. Once again, you're using the same formula. Someone tell me what that formula is. I'm going to rewrite it down. Easy XP here. You have to think about if you're in radians or degrees, just like we said earlier. Radians or degrees, and then write down the formula. Quiet raised hand. Volunteer. Not a one of us. 2 people know. Chewy, give it a shot.
Which one were you using?
Yeah, are we using the blue one or the red one?
We're going to use
Degrees or radians? We're going to use not the blue one, we're going to use the red one because we're in radians, we have a pi. So if this central angle has a pi in it, we're going to be using the one on the right, the radians. So read to me the radians formula.
0 or whatever the beta.
Theta?
Yeah. Beta. Over 2 pi. Or, and then what was sector area?
Sector area
Over there. Yes.
over the total area. Thank you. Can you please turn in your card, Chewy? Marble. Good. I cannot aim. There we go. There's a marble. All right, so I need someone to fill in for this formula. If I don't see anyone new, I'm going to cold call. I need someone to fill in this formula. 2 pi is already filled in. One of these is going to be a variable, the thing that we're trying to solve for. The other 2 things that I'm going to be plugging in, you'll need to find on your own. So, who knows what 2 things to plug in? Where do I put pi over 3? Where do I put 4? Those are our 2 numbers. Quiet raised hand. Where do they go? Even if you have participated, I want to see if you know it. Beverly knows. India knows. I'm going to call on someone new, though. Aurelio's waving his hand to say he knows it.
I'm just saying, is this right?
Yeah, read it to us, Aurelio.
Oh, it is?
Yep.
So it's pi over 3.
It's going to be pi over 3 for the numerator.
And then 2 pi for the denominator equals 4 over x.
Is equal to 4 over x. Aurelio has that correct because we are trying to find the area of the circle. So this total area of the circle on the bottom should be our unknown, our variable. The unknown is x. This area we're calling x. So that's our bottom right. The sector area, it told us that the sector area is 4 up here. So the sector area is 4. And of course we know that our angle was theta, so angle is pi over 3. All right, so far so good. Now we need to keep it, change it, flip it again. Who can keep it, change it, flip it on the left-hand side? 2 people know how to keep it, change it, flip it. I need more people. 3 people. All right, Anna, go for it.
So you keep 2 over pi over 3 times I guess 1 over 2 pi.
1 over 2 pi, there it is. Because that 2 pi is secretly a 2 pi over 1, so I flip 2 pi over 1, which is really 1 over 2 pi. Thank you, Anna. You got a marble for the class. Thank you, and more XP. I'll remember at the very end. All right, so the left-hand side has been changed by the keep it, change it, flip it form. And now on the right-hand side, nothing has changed, so I'm going to leave that as 4 over x. 4 over x. Nothing has changed on the right-hand side. I need to simplify that green fraction on the left. That left-hand expression, the pi over 3, 1 over 2 pi, I need to simplify by crossing things out and then simplifying. Who can do that for us? I need to simplify the green part of my equation. Who can simplify it for us? Martine, go for it.
Can you cross out the pi?
You can indeed cross off the pi, and I'm left with
3, 1 over 6.
1 over 6, and then the right-hand side has not changed, 4 over x. Thank you, Martine. It is indeed 1 over 6. Thank you. All right. This is one of those cases where we can't just get rid of the 4 and get x by itself. This is one of those cases where we have to use a different technique. So last time, Beverly told us to just multiply by 25 on both sides because x was being divided by 25. But this is a different scenario because x is underneath the 4. 4 is being divided by x. So there's a totally new technique that we're going to use here. India's making the symbol, and she's correct. Who else knows what we're supposed to do here? When we have 2 fractions that equal to each other, this is a fail-safe way. It will always work. How do I solve fraction equal to a fraction? Anyone else aside from India and Ellery? Brian, go for it. Yes, there it is. Cross multiply. So when we cross multiply 1 times x, you want to do that for us, Brian? What is 1 times x?
1x.
1x, there it is. And what about 4 times 6? 6 times 4 is? 6 times 4 is the same thing as 6 times 2 times 2. So what's 6 times 2?
12.
12, and then 12 times 2?
Not gonna lie.
Don't know? Okay. You want to call on someone for help? 24. All right. You both get your cards in. Thank you. Sorry for quizzing you on the spot. You did a good job. X is equal to 24. We're done. We don't even need to divide both sides by 1 because that's the answer. X is equal to 24. The area of the circle is 24. Box it. Brian and Sam get their marbles in. Thank you. And finally, before we move on, are there any questions? All right. Finally, we have example 3 on the back. All right. So we'll give some easy XP again. I shouldn't have read the last one. Who wants to read this one? Easy XP. Just have to read it. Oscar.
A circle with a sector area 3 pi has a central angle of 240 degrees. What is the area of the circle?
Perfect. All right. So thank you, Oscar. You can turn in your card. Next question. Are we in radians or degrees? Quiet raised hand. How many people have an... Well, I think everyone's going to have to vote on this one. You have one of 2 options. We'll say radians is 1. Degrees is 2. Hold up 1 or 2. Is it radians 1 or degrees 2? What is our central angle measured in? Radians 1. Degrees 2. Everyone hold up 1 or 2. Let me see your fingers. Martine is the classical joker. He's holding up 3. All right. Most of us are saying it correct. It is degrees. I said you are a joker.
I'm not trying to.
You know, there's 2 of them in a deck of cards. All right, so we are in degrees. That means we're using this left-hand equation. I will take the liberty of copying that equation down. When I copy that blue equation down, I have theta divided by 360 degrees is equal to the sector area
My dad said he wanted me to do
over total area. You already are funny, Martine. There is the formula. I'm using the formula for degrees because I know that this formula for degrees is being used since we have this unit of degrees for our central angle. From there, I need to fill in this equation with 2 things that we know. This 3 pi, this 240 degrees go somewhere. Where do they go? Quiet raised hand. Where do I fill them in? I'm going to call in someone brand new for this. Cheyenne, go for it.
240 over 360
360 equals 3 pi over x, like that. You are indeed correct. We're looking for the total area of the circle. What is the area of the circle? That means that that is going to be our x. That is going to be our x. All right, and very similar to our last problem where we can't just we can't divide by 3 pi on both sides. We need to do something to solve for x. What is that method again? Quiet raise hand, easy XP. You just need to regurgitate what someone else has said. Yeah, Caroline, what are we going to do? Yep, and what do I do? So 240 in x is going to turn into 240x, and 3 pi times 360 degrees. Ooh, that's going to be hard. You think you got that? All right, I'll help you. 360 times 3. 3 times 0, 0. 3 times 6, Caroline. 3 times 6, 18. Carry the 1. 3 times 3, 10. Oh, yeah, here. You already add the 1. So 360 times 3 pi is, Caroline? 1080 pi. There it is. Thank you, Caroline. You can turn in your card. Marble's in there. And finally, my last step. My last step. Quiet raise hand. Sam, go for it. Yep, divide both sides by 240. X is equal to 4.5 pi. There it is. And just to double check, making sure we are on the right track, 1080 divided by 4.5 is indeed. Wait, what is it? What's going on here? Oh, I forgot the 0. That's what I'm going. 1080 divided by 240 is indeed 4.5. 4.5 pi is our answer. Box it. Thank you, Sam. There's a marble. All right, so quiet raise hand. Or sorry, not quiet raise hand. If you have a question, you can do quiet raise hand. Are there any questions on this entire lesson? You have 2 formulas that you need to know. They're basically the same formula. One is 360, one is 2 pi. They're the same measure, just in different units. Any questions? Yes. I hurt your feelings by saying that you're funny? Okay, you're not funny? I said you were a joker. All right.
Wait, can you go
Up a little bit to example 2.
Do I have to put anything for the second?
For a sector? A sector is all of this stuff.
Oh.
Yeah, so if you want to do an arrow to make sure that you know what's going on, sector is all of this stuff. All right, that concludes the notes. Write your summary. Stuff is on Khan Academy already.